Almost any data structure that you use, you will be handling only one value at a time, right? But what happens when you have to deal with a pair of values? For example, country and its capital, some commodity and its price, a student and their marks. What do you do then? This is where the hash map data structure comes in. And in this video, we will explore what is it all about. Hello friends, welcome back to my channel. In one of my previous videos, I talk about the hash set data structure, how we are able to effectively use it and remove all the duplicates while increasing all the speed as well, correct? On a similar idea, we also have the hash map data structure. So in this video, we will talk about what is this hash map data structure, how do you store values in it, what are its use cases, everything about it. And then we will also do a live demo so I can actually show you how this works in your code. So without further ado, let's get started. Before starting off with our hash map, let me quickly give you some overview. So in one of my previous videos, I talk about the hash set data structure. This is a special data structure where you can never have duplicates and all the operations happen in order of one time, right? If you do not know about the hash set data structure, I highly recommend you to check out that video first. You can find the link in the description below. In this video, we will be talking about the hash map data structure, where this deals with a pair of values. And in my subsequent video, I will be talking about hashing, the basic underlying concept on which both of these data structures actually work. So let us dive into our hash map now. To understand things, let us start with an example. I give you this data set where I have some fruits and I have their prices, correct? And I ask you that you have to store this information in some way that I ask you, okay, what is the price of banana? You give me 30. I ask you, what is the price of papaya? And then you give me 45. And I can also ask you, okay, the new price of banana is 35. Then you have to update this value. And I can also tell you that, hey, remove mango from this data set. So you have to remove this as well. So how can you store this value such that all of these operations are very fast? The first data structure that comes to my mind is, okay, maybe I can store all of these values in an array. So now when you have this array, okay, you can query all the values, you can update them and you can delete them, right? But how do you know that 10 is the value for apple, 50 is the value for mango and 45 is for papaya? How do you keep a track of it? This is where it will get confusing. Or you could also think that, okay, I can create a linked list where I will store apple. And then in the next pointer, I can store its value, right? 10. And then I can create a next node where I will store banana. And then I can store its value, 30, right? So now if you ask me, I can travel over this list and give you that, hey, the price of banana is 30. If you ask me to remove, I know how to remove nodes from a linked list, right? So you can create this structure now. But the problem with this approach is that you are taking a lot of space to store all of this information. And when I ask you to perform those operations, you are taking a lot of time to iterate through this entire structure, right? So that is why we need some kind of a data structure to store values in pairs, right? Because all of these values are associated with themselves, correct? So this is why there is a need for an additional data structure. If you notice closely, the data structures that we have been dealing with are arrays, linked lists, binary trees, and hash fits. What is common among all of these data structures? All these data structures can handle only one value at a time, right? In an array, you can store one value. In a linked list, you are only looking at one value at a time. Same is for binary tree and same is for hash fit, right? That is why there is a need for an additional data structure where we are storing a pair of values so that we can deal with them together and at the same time. Also, we have to make sure that it is fast, right? So now you know what was the actual need of a hash map data structure. Why did you need an additional one? Let us just take a moment and try to realize some of the use cases when this kind of a map or this kind of a pair of values could be helpful for us. So let us say I give you that, okay, I have a classroom and I have some indexes of children. So there is a bunch of students and a index number associated with them. How do you store all of them? So I can say that, okay, if it is a classroom, what I can do is I can create some kind of a string array and I know that, okay, at 0 it is Emily, at 2 it is Jack, at 4 it is Albus. Correct, right? So if you ask me, okay, which student is on roll number 3, then you can just look up the third element and then say, hey, Shalina is at number 3, right? But what happens when your data type changes? Let us say I ask you, okay, store all the countries and capitals. What will you do then? So this is where you can use a hash map. So in your map, you know that, okay, these are all my countries and these are all the capitals. So now you can start storing all of these values. In a hash map, you will say, okay, Australia's capital is Canberra, the capital of China is Beijing, the capital of India is New Delhi, right? So you can see that, okay, you are storing a pair of values. The interesting thing about a hash map is it is not necessary that both these data types should be same. You can also have a string and an integer hash map. So let us say I want to store, okay, these are all the students in a class and these are their marks. So I can have one more hash map. In this map, what we are storing is that, okay, Rose has 88 marks, Emily has 95 marks, right? So this is how the use cases of a hash map work. One important thing that you must know about a hash map is that all of the values on the left side, these are known as keys, and all of these values on the right side, these are known as values. So a hash map is a composition of key value pairs. So now that you have the knowledge of this hash map, can you approach the original problem in some newer way? I am once again taking the same example, and this time we will see how a hash map works. So I have this data set with me, right? All the fruits and their prices. I will take each entry one by one and start to create a hash map. So when I read my first value, I see apple and a 10. As soon as I will enter this value in my hash map, my data structure will start to look like some kind of a table. And from this table, we can query and even add more data. So let us try to add the second piece of information that we have. So you see, when we add elements in our hash map, more and more rows are added to this table. Notice that this hash map is not ordered. That means these values will not be added in the same order as I am reading from my dataset. So it could be possible that now when I enter mango, it could get inserted at some other position. So it is possible that now when I add mango, my hash map can look like this. What I mean to say is that this hash map is unordered. So now let us say you want to look up values. You want to ask me that, hey, what is the price of apple? A hash map can directly tell you that, okay, the price of apple is 10 and you will get 10 on your screen, right? Similarly, you can say that, okay, what is the price of mango? Hash map can do this operation in order of one time and immediately give you 50 as your output. So this is really speeding up things, right? Now let us say I want to add more values. Let me try to add papaya. If I try to add papaya, it can go anywhere in your hash map. Your hash map can start to look like this. Now let us say you want to update some values. You say that, okay, the price of apple has now changed and the new price of apple is 15. You will call an update operation on your hash map and then the value of apple will be immediately updated to 15. If you will try to query now that, hey, what is the price of apple? You will get 15 as your output, correct? Similarly, what you can do is you can also remove values from your hash map. What you can do is you can say that, okay, if you want to remove papaya, you can just call a delete operation and papaya will be simply removed from your hash map. So you can see that these are all the possible operations that you can perform on this hash map data structure. One important thing to notice over here is that just like in a hash set, you cannot have duplicate values, correct? In a hash map, you can never have duplicate keys. So what I mean to say is that you cannot have another entry in here that says mango and it has a price of 55. This will be totally invalid. This can never be possible. If you try to do something like this, the actual value of mango will be updated. So you have to be a little careful about it. So now let us just try to summarize all of this and do a live demo so that I can see you how this is actually working in action. What we will try to do here is we will create the same example. We have some fruits and their prices, right? So what I want to do is I want to create a hash map where the key is a string, right? That is the name of the fruit and the value is an integer. So I am creating a string and an integer hash map. So let us call it fruit prices map. So this is how I know that this hash map will be storing the fruit name and its prices, right? So now let us try to add some values to our map. What we want to do is we want to add the fruits and their prices, right? I will do fruit prices map dot put. And in my put command, first I will say apple, that is my key, and then I want to put the price, that is 10. So this statement will put the price of apple as 10 and add it to my hash map. I am using the Java programming language, but you can use any programming language of your choice. Most of the modern languages like Python, C++, JavaScript, they all have inbuilt functionalities for a hash map. So now let me try to add one more value. I added two values, right? Let us try to see how our map looks like. I will just go ahead and run this program. You can see that I got my two values, apple and banana, correct? Let us say I want to add more values to my hash map. The price of mango, let us say I put it as 50. We can once again try to print our map and see if the values got updated. Okay, so now you can see that when I added a new value, mango, it got inserted in the middle, correct? So this is what shows that this map is not ordered. So you cannot rely that, okay, if I added the values in 1, 2, 3, they will be in the map in the same sequence. So now going ahead with more operations, let me say the value of apple has now changed. The new value of apple is 15. So to update values, I need to put the same operation. I will do a fruit prices map dot put, and I will once again do apple and then my new price. Once I do my new price, let me once again try to print my map. So as you can see that once I have updated this value 15, this value has been reflected in my map, correct? So now you understand how we are adding and updating values in our map. Now you know easily that if you want to add papaya, how you can do it. Try to do it as an exercise on your own. The next part is removing elements. If you have to remove, you just want to say that, okay, remove this key, because both of these values are associated with each other, correct? So let us say I want to remove banana from my catalog. What I will just do is fruit prices map dot remove, and then I will put in the key that I want to remove. I want to remove banana. Let me try to print my map again. And there you go. We have removed banana from our catalog, right? So this covers all the basic operations on a hash map. You know how to create one, you know how to add more values, update more values, remove values, and you can also check if a value is present in your catalog or not. Let us say I want to check if I have peaches available. So what I will just do is, if fruit prices map dot contains key, and over here I will mention which key I want to search. I want to search if I have a peach or not, right? So if I have a peach, what I will do is I will say, okay, present, else I will say that this key is not present. I run this code again and I get not present on the screen, correct? Instead of peach, if I was searching for a mango and I run the code again, this time I get the output as present, because indeed mango is present in my hash map, right? So this kind of covers all the basic operations that you can perform on a hash map. The best part is that all of these operations, checking for a key, removing elements, updating elements, all of them happen in an order of one-time complexity. And that is what makes hash maps really, really fast and very, very important. I hope I was able to give you some idea about how the hash map data structure actually works. As per my final thoughts, just take a moment and look back at all the problems that you have solved so far. Were there some problems where you had to associate a pair of values and then work upon it? Maybe you had to update them. Maybe you had to retrieve a value based upon certain key. When you look back at those problems now, can you come up with faster solutions? When you were going through this video, did you face any problems? Tell me everything in the comment section below and I would love to discuss all of them with you. As a reminder, if you found this video helpful, please do consider subscribing to my channel and share this video with your friends. This motivates me to make more and more such videos where I can simplify programming for you. As I told you, in my upcoming videos, I will be discussing the underlying concept of hashing, upon which both the hash map and the hash fed data structure actually works. So stay tuned. Until then, see ya.